everyone. In this video, we are going to discuss about one program. That is, we are going to generate the Fibonacci series. So first, let's type the comment section. This is the program to generate Fibonacci series. Yes, before doing this program, at first we must get familiar with that series. Actually, when we are taking the Fibonacci series, first we will take the number 0 and then we will take the number 1. The sum of these two numbers 0 plus 1, we will get 1. So that will be the next number in your series. And in order to find the next number in the Fibonacci series, we have to find the sum of the last two terms in that series. For example, 1 plus 1, we will get 2 here. So that this is the next term. In order to find the next term in this series, again we have to take the last two terms in this series. For example, here 1 comma 2. That's why here we have to type 3. And then 2 plus 5, 2 plus 3 we will get 5. And then 3 plus 5 we will get 8. So in such a way the series will move on. So how can we implement this logic means we may take f1 is equal to 0 and we can take f2 equal to 1 and we can take f3 equal to f1 plus f2. So it means we will get 0 plus 1 equal to 1. So after doing this one, we have to change the value. How we have to change the values means actually the f1 value here is 0 and f2 value here is 1. The next thing in next iterations we have to change it as f1 is equal to 1. It means I'm going to assign the value of f1 is equal to f2 and then I'm going to set f2 equal to f3. So the f2 equal to 1. It means I'm going to set f1 equal to f3. Just swapping operations. Next what I'm going to do it is I can set f3 equal to f1 plus f2. So in such a case means I will get 1 plus 1 is equal to 2. For the next iterations, I can set f1 is equal to f1 is equal to what's the value of f2? That will be the value of f1 here. So f2 value here is 1. So here also we can set f1 equal to f2 and then f2 equal to f3 value, right? So here we have to substitute 2 and we can write it as f2 equal to f3. Then f3 equal to f1 plus f2 which will be equal to 1 plus 2. 1 plus 2 equal to 3. And for next iterations, in the same way, we can write f1 is equal to 2. It means f1 equal to f2. And then f2 equal to 3. It means f2 equal to f3. Then f3 equal to f1 plus f2 such that we are getting the value 5. So kindly notice this process. So for each and everything we are calculating the sum of F1 and F2, but the values of F1 and F2 are getting changed. We are going to store the value of F2 to the F1, and then we are going to assign the value of F3 to F1, and then we are calculating the sum of the F1 and F2, and that resultant value which will get stored in F3. So what we are going to do it here is, since this process is again and again repeatedly happening, we are going to make use of the loop structures. So this is a logic for implementing our program. So next, I have included all these things in the comment sections. Next, we can do the program. We can start our program with a comment section. So has include stdio dot h, and then hash include conio dot h, and then we can include void main. Oh, sorry, void main, and then open curly braces, closing curly braces. Here we can write what are the input variables needed for this one. You can print the number of terms to be displayed. So for example, you can take it as n. And next, you can clear your output screen, so CLR SCR. Then you can prompt the user to enter the number of terms to be displayed. Then we can close this one. Then in this scanf, we can put percentage D address of n. Yes. So initially we have to assign the values 0 and 1 to some variables. So here I am going to declare the variable as n comma f1 comma f2 comma f3. So here F3 is the output variable and N is the input variable, and F1, F2 are the temporary variables that I am using to implement the operations, right? So here I am assigning F1 equal to 0, and then I am setting F2 is equal to 1. So initially I have to print the these values. That's why here I'm just printing it as percentage D, comma percentage D comma percentage D. Yes, percentage D comma percentage D. And then we can print F1, F2. That's all. So next, after printing 0 and 1, then we can make use of the for loop. You can, for making use of the for loop, we have to make use of the counter variable. So here you can declare the variable I. And here I am going to start the value of 5 with the value 3. The reason is the first two terms that I have already displayed here as 0 and 1. That's why in order to calculate the next term, I am starting it from I equal to 3, and then I less than or equal to n, and then I plus plus. Then open curly braces, closing curly braces. Here we can write F3 equal to, first we have to calculate the sum F3 equal to F1 plus F2. Right, then we can print that value. So printf percentage D comma, and then D comma, we can print the value of F3. Next, we can interchange the values. So here we can set F1 equal to F2, and then we can set F2 equal to F3. So that's all. That's all. Next, what I'm going to do it here, outside the loop, I'm just going to type get ch, and then I have already closed this main functions. That's all. So once again I'm revising. um, First we have included the void main section, and then we have declared the variables. We are prompting the user to enter the number of terms to be displayed. We are getting the limit from the user by means of the variable, and then we are initializing the temporary variables as f1 equal to 0 and f2 equal to 1. We are printing those terms before the loop itself. So already we have printed two terms before the for loop itself. So since we have displayed the two terms, we have to initialize the for loop with the value of I is equal to 3. So from the third term, we are displaying it by using the for loop. Here we are first calculating the sum of the variables f1 and f2, and the result which will get stored in f3, and that value has been printed here. And then next we are interchanging the values for the next iterations. So we are setting here as f1 equal to f2 and f2 equal to f3. It means initially value of f1 is 0 and the value of f2 is 1. So 0 plus 1 will be displayed here. Then I am going to set f1 equal to f2, means I will get f1 equal to 1 and f2 equal to 1. So next, 1 plus 1, 2 will be calculated, and then 2 will be printed. Then again I am changing the value. So f1 equal to 1 and f2 equal to 2. Then 3 will be calculated, and that value will also be printed here. Again we are setting f1 equal to 2 and f2 equal to 3, such that 2 plus 3 5. So 5 will get stored in f3 and 5 will be displayed here. So this process will be repeated again and again until the value of I exceeds the value of n. So when it exceeds, it comes out of the for loop. By that time it will just get a character from the user and execution gets stopped. So let's first save this program. I am saving it as fibo.sim. Then we can compile our program. Now a message. Then we can run our program. I am going to enter the number of terms to be displayed in my series as 5. It's wrong. It's not, of course, it's not wrong. It's printed as a 0, 1. I haven't mentioned comma here, so here I have to mention the comma. Don't be scared after seeing the output. Being a programmer, we have to debug our program efficiently. So kindly do the modifications. Now you can run your program. And I'm typing the number of terms to be displayed in the series as 5. Now see the result: 0, 1, 1, 2, 3. Next I'm going to again run it. Here I'm going to give it as 12. Yes, of course, the series are generated very successfully. So this is the concept of generating the Fibonacci series. I hope that you have understand the concepts clearly. In case if you are having any queries, kindly post your queries in the comment section. Thank you.